Welcome everyone. In this video, let's look into our day 4 of the professional course. This day 4 course is divided into 5 different sections. In that, we'll be looking into section 3, which is custom modeling basics. See, in all our previous onboarding sessions, we would have talked in detail about our first method of modeling, that is catalog based modeling, right? Where we provide the designers with different catalogs of models, including non-modular component, modular cabinetries, finishes, handle style, door style, etc., which designers could use, place it in their project, and design the space based on their requirement. And the advantage of this first method of modeling is first time efficiency, since designers, they don't need to do everything from the scratch. We already have a catalog of model, finishes, and etc., where they can just pick and drop in their project and they could get their project done. But you should be aware that design is subjective in nature, and cataloging all the components which designer would need in their process is practically not possible, because we have n number of design requirements which needs to accommodate n number of components, which means a designer might easily come up to a point where they need something that is custom, which is not available in our catalog or which couldn't be even cataloged. In those cases, the designers could go for the second method of modeling, which is custom modeling. As the name suggests, any custom requirements which is not there in our catalog could be completely modeled from scratch in your custom modeling. It follows the exact modeling prospectus of your conventional modeling tools like SketchUp, 3ds Max, etc. And you don't have to worry about whether that model could be translated further in this process. You can generate your 3D renders, 2D line drawings for your custom model too. Only restriction is that you won't be able to generate cut list for the custom modeled components if you have subscribed for our cut list product. So now let's just look into how you can first get inside your custom modeling window, because custom models can't be done in this main modeling window. For that, on the left here in your vertical tab at the last, you have something called advanced tool, right? Click it and this will open up your advanced tool tab. In this, if you notice, there is something called custom model at the bottom right? Click it and this will open up your custom modeling window. And this is the window you could use to design something that is completely custom in nature. And for that, first let's just take some time to understand the UI of this custom modeling window. So on the top here, you will see the menu bar of the custom modeling, which will have 4 important tools here. One is your file option. If you place your cursor, it will open up a drop down. In this, you will see 2 important tools. One is your import and save. Import is nothing but within your custom model, you should be able to import your CAD files or image file for your reference. And if you already have a specific SKP model and you would like to import it in your project, you could also do within your custom model as well. And the second important tool here is the save, using which you will be able to save all the components which you created in your custom model, and you can finally click on finish, so that you will exit this custom modeling window and all the models which were created in your custom model will be updated in your main modeling window. In default, you don't have to worry about this process, because once you click finish, it will automatically save the project and it will be updated in your main modeling window. And following your file, then comes in your undo and redo. Shortcut is Ctrl Z and Ctrl Y, using which you can undo or redo any changes which you did in your custom model. And then comes in clear. Always this clear tool represents delete. So if you like to delete all the custom model components in this project, just click this all model under clear. It will wipe off all the custom model components in your project. And in this custom model, you have a feasibility to create a reference lines as well. If you like to delete all the reference line together, then you can click on the second option, which is reference line segments. It will specifically delete all your reference lines. Apart from these, on the right here, you have your finish. Like I said, once you completed your custom model in this project, you can just click on finish, so that all the models which were created in custom model will be updated in your main modeling window. Then you can proceed further for your rendering, 2Ds and so on. Apart from your menu bar, you have an horizontal toolbar here, right? This horizontal toolbar will have all the important tools which you need to do modeling in this custom modeling window. Apart from that, on the right hand side, it will have a property window. It will show some basic properties of components which are created in custom model here. Apart from that, on the left, you could see 3 different tabs in this vertical bar. In that, the first tab is your modeling library. This contains some basic ready-to-use 2D and 3D geometries which you need in your modeling. And the second tab here is your material tab. And yes, in custom model, you have a feasibility to apply material or finish to your surfaces. And the last vertical tab here is your private model. We'll be talking in detail about this private model in our further sections. Apart from your vertical tab, at the bottom here, you have a feasibility to shift to your 2D and 3D viewport here. And right next to it, you have an eye icon, right? This is your hide and unhide options. And right now, can you notice the default display mode is your material mode, where you can't see the edges of a space or your component. For that, just click on this display mode and make sure you select this third option. Shortcut is Ctrl T. Shortcut is Ctrl 3. Just click it. Your edges of the models will be precisely seen. So this is what when it comes to the user interface of your custom modeling window. So now let's just look into how you can create models within your custom modeling window. So for that, you first need to understand some 4 categories of modeling tools which are available in your custom model. In that, the first category of tool is your 2D geometry creation tools. In your top horizontal toolbar here, can you see this option? This is your line tool. If you place your cursor, it will open up a drop down which will have different natures of line. So your typical straight line tool, or if you're looking for an arc tool and a tool to create a Bezier curve. In that, first let's just look into your line tool. Shortcut is here. If you click it, just like your conventional modeling, you can draw a line here. So you can just click on the starting point and then you can take your cursor based on which the line will be created. Can you see here? And in any geometry creation process in custom modeling, you will see 3 different axes here, which is your X, Y and Z axis, where your X axis will be in green color, what you're seeing, and your Y axis will be in red color and your Z axis will be in blue color. And if you align your geometries in that specific axis, the edge color of the geometry will also be in the same line. So if I'm drawing any line in my Y axis, it will be in red. If I draw a line in my X axis, it will turn green. Same applies for the Z too. And the shortcut to define this axis is your arrow mark. So if you press your top arrow mark in your keyboard, you can only create a geometry in your Z axis. If you press your left arrow mark in your keyboard, you can create geometries in your X axis. And if you press your right arrow mark in your keyboard, you have options, but you can create geometries in your Y axis. And this process, what we explained, is exactly similar to your SketchUp. So now I have to draw a line in my Y axis at a distance of 1500 mm. So for that, just place your cursor in that axis, your line color will change, and you can just type in the length. Type it as 1500. Can you see on the right hand side in your parameter window, that unit will be typed. Once that is done, just press enter. We precisely created a line of 1.5 meters in length. And you can continue this process to create n number of continuous lines. So in this case, let me just create another line of 1200 mm. And for now, if you notice, all these are your conventional lines. But as soon as I close this line, you will see it's been created like a 2D geometry. Exactly similar like your conventional modeling window. So now if I want to create an independent arc, I can just select the second option here. And now I can create a typical 3-point arc. Just select your first point, select your second point, or you can even type in the distance of the second point. And now we can control the curvature of this arc. If not, you can even type in the height of this arc too. Once done, an independent arc will be created. If I create a same independent arc attached to this surface, it will create that into a surface since the line is already enclosed on the other side. Right next to the knife tool, you will see a square icon, right? If you place your cursor, this will display some important 2D geometry tools in its drop down. In that, the first tool here is your rectangle. If you click it, you will be able to create a rectangle. Just click on the starting point, move your cursor and randomly select another point. You will create a rectangle, or if you want to create a rectangle precisely, just like we addressed in your previous section, while drawing your rectangle, first type in the length of this rectangle. In my case here, I want the length to be 1 meter. And once that is done, I can press tab button in my keyboard to shift between the dimensions. So this way, From the length, I can just shift it to width. Can you see here? On the right hand side, I have length and width, right? So once I tapped in the length, I'm pressing my tab button so that I shift to my width, and now I can type in the width. In my case here, let me just go for 1500. Once that is done, press enter. We precisely created a rectangle which is 1 meter in length and 1.5 meter in width. And if you like to create a circle, then click on the second option here. Just click on the center point, and now we can type in the radius of this curve. Can you see here? And in the process of creating any curve in your custom model, you will notice one important thing here. So though we are creating a circle here, the edges of the circle is not smooth, right? It is a bit rigid. It looks like a polygon. That is because just like your SketchUp model, your custom model doesn't have a capability to create a curve, because both are planar modeling tools, which means they have capability to only create planes, not curves. And if you want to create a smooth curve, then you have to increase the number of edges or number of segments so that it appears to be curved. And in this case, the reason why the curve appears a bit rigid is because on the right hand side, can you see the number of edges is 24. For a circle of 1 meter radii, 24 edge is minimum. So that is why it is looking like a polygon. If you want to make it appear smooth, then increase the number of edges, as simple as that. So right now I am in my radius unit here. So if I want to edit the number of edges unit, then I have to press the tab button in your keyboard so that I can shift between the properties and I can edit it. So now instead of 24, let me just make it as 60, and again press your tab. Can you see here? Now the curve looks smooth, right? So this is how you should be able to create a smooth curve here. And not only in custom modeling, in this tool in general, if you use any curve creation tool, you will eventually find this option named number of edges, using which you can increase the number of segments and make the curve appear smooth. Let's just look into how we can create a polygon here. For that, go to the same tool and you have a third option here named polygon. Just click it, just select a center point and start drawing a polygon here. And since it is a polygon, you can define the number of edges of the polygon based on which the nature of the polygon changes. So if you are looking for a pentagon, you could have the number of edges as 5. If you're looking for an hexagon, then make the number of edges as 6. If you're looking for a decagon, then make the number of edges as 10. Can you see? So this is how you should be able to create a polygon in custom model. And if you like to create a 2D arc surface, instead of just using this arc tool here in line, you have a specific arc 2D geometry tool itself. Now what if I want to club two different geometries and make it as a custom geometry? Simple. Just like your conventional modeling tool, just select the line which is dividing that surface and delete it by pressing the delete button in your keyboard. Can you see? This has become one custom shaped geometry. So here, I've created multiple surfaces adjoining each other, right? Now all the surfaces are independent. I can separately select it, I can move it, I can modify it. If you want to club all the surface into one single custom geometry, then obviously you have to select the line which is dividing it and delete it, right? So for that, like I told before, you could just specifically select that line and press the delete button. Or if you want to delete multiple lines at a time, then you can just multi-select by holding shift. Can you see? That way I should be able to delete multiple lines at a time, making that into one single geometry. Or you have your erase tool here, just click it, and now using your erase tool, just select the line. That specific line will be deleted. Can you see here? But your SketchUp eraser tool has an intuitive way of erasing a line, right? You could just drag it across a single or a multiple line so that it will be deleted, correct? That is also feasible. For that, you have to hold shift in your keyboard. And now if you just left click and drag it across multiple lines, can you see? All those selected lines will be highlighted. And now if you just leave your cursor, all the selected lines will be deleted in a single instance. So this is what your eraser tool is, using which you can edit a 2D geometry. So these are all your different 2D geometry creation tools. The first two tools in your horizontal toolbar here. So now let's just look into how we can create a 3D geometry from the scratch. So for any 3D geometry, first you need to have a 2D geometry, right? So if you want to create a cuboid or a cube, you first need a rectangle. Or if you want to create a cylinder, you first need a circle. In the same way, you need a 2D geometry first to create that or make it into a 3D. So that way I have a rectangle tool here. If I want to create a cuboid, just select that rectangle tool, and here right next to your rectangle tool in your horizontal toolbar, you have something known as push pull, right? Shortcut is P. If you click it, now just like your SketchUp, you should be able to use this tool to extrude this surface. Can you see here? And while extruding it, you could just click your cursor based on which it will be extruded to a certain height. Or if you want to extrude it precisely, then in this extrusion process, just type in for how much unit you would like to stretch it. In my case here, I would like to create a cuboid which is 1 meter in height. So I can just type it as 1000 mm, press enter. Now can you see here? A cuboid is created. This is one important and most frequently used 3D geometry creation tool in your custom model. So if I want to create a cylinder, can you see? I could extrude it from the circle here. And apart from your push-pull tool, another important 3D geometry creation tool is your sweep tool. For the sweep tool, you need two important components. One is the surface or a profile, and another one is the extrusion path. Let me just give you an example. So here, if you notice, I have one surface here, okay, and I have a path. So now I want to extrude the surface on this three paths here. How can I do it? One conventional method you could think of is using your push-pull tool, right? So that way I could just push-pull it to this extent, and now I could just copy this, rotate it, and I could just again push-pull it on this direction, and then I can do the same process for this direction too, right? This way I should be able to extrude the selected surface on this selected path, right? But what about the corners? If you notice, if I do that process, your corners won't be articulated, right? It will be like a separated corner. But I don't want that. I want to create a seamless corner, just like how that surface has continuously extruded in that path. In this kind of a scenario, your push-pull won't be an apt tool. This is where your sweep tool comes in. So for that, like I said, you need two important components. One is the extrusion surface or a profile, and another one is the extrusion path based on which this profile need to be extruded. And once you have the two, first you need to select the path here. Path is nothing but the line or the edges of a surface. Okay, so I want the surface to be extruded on these three sides. So I'm just selecting these three edges by holding shift. Once I multi-selected the path here or the edges, now I could just use the sweep tool. Can you see here? Right next to your push-pull tool, you have your sweep tool. Shortcut is I. Just click it, and now you place your cursor on the surface here and just select it. Now can you see? Just in seconds, that specific surface is extruded to your defined path, right? And the best part is your corners will be perfectly articulated. So this is what your sweep tool is. Again, I'll repeat, for any successful sweep process, you need two components. First one is your surface or a profile, which you like to extrude. And second thing is the path in which the extrusion needs to happen. Just select your path here, which is nothing but the line. You can just multi-select your lines too if you have multiple edges. And once that is selected, use your sweep tool, shortcut is I, using which I have to directly click on the surface. Since the path is already selected, I just have to directly click on the surface. The extrusion will precisely happen to the selected path. So this is what your sweep tool is. See, this might look like some occasionally used tool, but trust me, this tool will really be useful if you have a requirement for any custom curvilinear wall panel or any custom curvilinear geometry. In those cases, attaining it using our conventional geometry might be a bit tricky or time consuming. But that is not the case with the sweep tool, because all you need is a single geometry and the path based on which the extrusion will automatically happen, right? And apart from your sweep tool, the third important geometry editing tool is your offset tool. Yes, you even have your offset tool to create an offset on a specific surface. So in this case here, if I want to create an offset on the surface, can you see here? I have an offset tool. Shortcut is here. Just click it, select that surface, and now I can create an offset. And in this process, I could even define the unit of the offset. So if I want to create an offset of about 150 mm, I can just type it as 150, press enter, it will be created. So now can you see this is one surface and this is the offsetted surface. And in this process, if you notice, I created an offset inside the surface. You could also do it outside the surface too. Can you see here? So this is how you should be able to create an offset for any surface using your offset tool. So these are all your important 3D geometry creation and editing tools which you will be quite often using in your custom modeling process. So now, once you created a geometry here, what would be your next immediate step in your conventional modeling? You might select that surface, right? So for that, you can just click on a surface, that specific surface will be selected. Can you see here? And if I want to select multiple surfaces, then I have to hold shift in my keyboard. That way I can select multiple surfaces. Can you see? But what if I want to select all the connected surface? In that case, then I could use this shift tool to multi-select individual surfaces here one by one, including the bottom surface. That way I can select all the connected surfaces together, right? See, for a simple geometry like this itself, it would have taken about anywhere between 5 to 10 seconds, right? What about for complex geometry? So this is where your double click selection method comes in. So if you want to select a single surface, like I said, you just click on that surface will be selected. But if we want to select all the connected surface, just double click that surface. Can you see? Just in seconds, all your connected surfaces will be selected. Remember, only the connected surfaces will be selected. If you notice, these surfaces are not selected because these are not connected with that, right? So these are all the different methods of selecting a surface in custom modeling. So once you selected a surface or a group of surface, what would be your intuitive process in your SketchUp? You will either make it as a group or a component, right? And in SketchUp, if you make something as a component and if you duplicate it and if you make any changes to the duplicated or the source component, the other duplicated component will also experience that change, right? But that is not the case with the group. Your group, though it is being duplicated or copied at multiple positions, it would act like an independent entity, right? So in the same way, you could also create a group in custom model. First, for that, you have to select a surface or multiple surfaces. And if you like to make it as one single group, can you see in this floating window, there is the second option named grouping, right? Shortcut is Ctrl-G. If you click it up, that's it. It has become a group. And if I want to edit this group, then I have to double click it so that I'll get inside that group. And now I can select the individual surfaces which are available within that group. Almost a similar logic like your SketchUp. Then not only that, if I want to duplicate any group or a surface, Ctrl-C is the shortcut. Or in your floating window, can you see you have a copying option? Shortcut is Ctrl-C. You can use any of it. And now I can precisely select the point where you like to duplicate. And I can duplicate it. Can you see here? So this way I'll be able to duplicate any surface including a cube. And now you will notice one interesting thing here. If I just edit any of this group here, it could be a duplicated group or a source group. If I just double click it, and if I make any edit here, can you see it is also getting updated in the other groups as well. So even though we call it as a group, it literally behaves like a component in SketchUp. See, this is an advantage which you'll get if you want to edit multiple similar components at the same time. But you might not have this requirement often, right? So that way, if you want to make any group here as independent, in that case, just select that group. In the same floating window, you will notice there is something called disassociate the instance, right? This chain breaking icon, just click it. And now it will load and it will disassociate this group from your source group. So now if I just get inside this group, if I make any edit here, you will notice it is not affecting my source group. Can you see here? So this is how you should be able to disassociate a group. And now if we want to ungroup something, in that case, just select that group. In the same floating window, you will see this ungroup option. Can you see here? Remember, you will only see an ungroup option if you select a group. If you just select any surface, then first you have to create that into a group to ungroup it, right? So you will only see the group option. But once you select any group here, then you will see this ungroup option. Click it, then it will be ungrouped. Always remember, anything related to your group will be in this floating window. So in this floating window, you will have a feasibility to create a group. And once a group is created, you have a feasibility to edit that group. Can you see? This is what group editing is. Or you can just double click it to get inside it to edit. Or if you want to disassociate it, that will also be there in the floating window. You will have that chain breaking icon using which you can disassociate or make a group unique. And finally, if you want to ungroup it, it will be there in the same floating window, ungroup option. So anything related to your grouping process will be available only in your floating window. And apart from these modeling and grouping tools, there are some basic modification tools which you should be aware of. In that, the first one is your move tool, which is an important tool using which you can move a surface or group of surface or a group or group of group in different positions. So this way, if I want to move this by picking up at this point and place it exactly at this edge here, then I can just select it, and here in your horizontal toolbar you will see this move option, right? Just click it, select the pick point, and you could precisely move it. And in this process you could notice it can precisely detect the vertex of another geometry, and it can even detect the midpoint of that geometry too. Can you see? So that way I could position it and place it accordingly. So this is what your move tool here is. The second important modification tool is your rotate. So if we want to rotate any group or a component or a surface, then just select it. And here can you see right next to the move tool in this horizontal toolbar, you have the rotate option. Just select it, and just like your SketchUp, you will have this compass based rotation. So you can just place it on any surface, select the center point and select the reference point. And now can you see here, I should be able to precisely move. Where I could just manually select any point, it will be rotated, or I could even specify the angle of rotation. Can you see? So if I want to 30 degree in this axis, just type it as 30, press enter. Can you see? It will be done. So this is how you should be able to precisely rotate. And the next important basic modification tool is your scale tool, using which you'll be able to scale a surface or a group to your preference. So in this case here, let me just select this cuboid here. And now if I want to scale it up, can you see? There is this scale tool here which is present right next to the rotate. Just click it and you will see this pick toggles on all the surfaces of this cuboid, right? Using this, you will be able to scale it on a specific axis. So in my case here, if I want to scale this cuboid from this side, just click on the center point of that toggle and stretch it manually. Can you see here? Or if I want to just stretch it based on the another reference, I could even place my cursor on the reference points here so that the component will be stretched to that extent. Can you see? And not only that, if you want to scale it precisely based on the proportion. For an example, if I want to scale this side to about 1.5 times the previous dimension, in that case, just click it and drag it. On the top, can you see? It will show you the scale proportion. So now I said I want this to be scaled at 1.5 times the previous dimension, right? So I can just make this as 1.5. Right now it is. But if I want to precisely type it, first I have to go to that y-axis property, okay? Because I'm just stretching now in the y-axis. If I'm stretching it in my x-axis, then I can just type it here. Same scenario for the z-axis too. So if I want to edit my y-axis property, press your tab button so that you can shift between the properties to edit it. So that way I've shifted to my y-axis, and now I can just type it as 1.5, press enter. That's it. So now let's just look into your last and important modification tool, which is your flip or your mirror tool. Select that component, and here in your sub horizontal menu bar, can you see at the center you have a flip or a mirror option, right? If you place your cursor, it will open up a drop down using which you'll be able to flip the selected geometry in a specific axis. Can you see here? X, Y, Y, Z or X, Z. Or if you want to rotate it in any custom axis, you can even go for custom mirroring too, where you have to define the mirror point axis. So in this case here, I want to flip it to XY. So just click it. Can you see just in seconds the specific component is flipped in your XY axis. And still it is not completely flipped. Okay, it is just showing you a preview of how it would look if it flipped. And in this preview, if you notice at the top you have something called delete source, right? So what this delete source toggle would do was, in default it will be checked, which means your source will be deleted, only your flipped component will be available in the modeling. But if you want both your source and the flipped component to be visible in your modeling, then you can just untick it. And now can you see your source, which is this, and your flipped, both are visible, right? So this is what your delete source is. Okay, so this is almost similar of flipping something in your CAD. It will ask you, right, whether you would like to delete a source or not. Exactly similar to that. In this case here, I want both my source and the flipped component. So let me just untick delete the source. Once that is done, just press enter. Now can you see both are present? And now if you want, you can just select it, move that specific. Now can you see this one is my source and this one is the flipped. So with this, your basic modification tool is completed. So now let's just focus on some other important tools which are available in your custom model. In that, the first tool is your array tool. So for that, first select a geometry, and here can you see right next to your flip tool in your horizontal toolbar, you have something called array, right? If you place your cursor, it will open up a drop down. There you will see two types of array, which is your linear array and circular array, right? We would have already talked in detail about your array in your previous wall paneling and fall ceiling creation section, right? Almost the same process. So if you like to create a linear array, just click it up, select the source point, and now can you see all I have to do was define the center to center distance by typing in, or I could just manually select the point as well. I could also define the number of components which I like to array. So right now can you see here it has arrayed 4 because I've typed it as 4 number. If I want it as 5, just type it as 5 and press your tab button. Like I said, tab is the shortcut to shift between the properties to edit it. So now can you see here? So this is what your linear array. And just like what we addressed in your previous section, there are two types of linear array too, right? One is your fixed spacing, where you can just type in the center to center distance between the arrayed component, which is this one. And second one is your fixed total length, where you can just type in the overall length of this array, and the number what we are defining here will be accommodated within that overall length. And once it is done, just click it, press enter. Now you arrayed it. And just for your safety, the tool will automatically group all your arrayed geometries. Can you see here? So if you want, you can just ungroup it. That way you can just individually select the arrayed geometries here. So this is what your linear array is. Similar scenario for your circular array too. So if I want to array it in a circular way or your polar array, just click it, select the center point of axis and select the source point. And now can you see here? I could just type in the number of components which I like to array in a circular way, and I could just type in the center to center angle using the fixed interval. Or if I'm focusing on the fixed total angle, then I can just type in the total angle within which the number which I've defined here will be accommodated. So this is what your circular array here is. And apart from your array, another important tool here is your reference line. Do you remember at the start of the section I told you have a feasibility to create a reference line, right? You could do it using this tool here, which is reference line. And the shortcut for it is T here. And here when it comes to reference line, we create 4 types of reference lines here. One is your conventional reference line, which is your X line in your CAD. So for that I could just select the first point and create one endless reference line here. Can you see? I can also do one in the vertical point. And now if I want to create another parallel reference line to this, just place your cursor on the existing reference line, click it, and from there you will be able to define the distance at which you would like to create another parallel reference line. So in my case here, I want to create another horizontal reference line at a distance of 1 meter. So I can just type it as 1000 mm, press enter. Can you see? We placed another horizontal reference line at a distance of 1 meter parallel to this. Same scenario, vertical too. So this is your first type of reference line, which is one of the commonly used reference line during your modeling process. The second type of reference line is your line segment. Right? Line segment is almost similar to your first type, but instead of creating an endless reference line, you can define the length of the reference. So in this case here, if I want to create a reference line for a length of about 1.2 meters, so I can just type it as 1200, press enter. Can you see? A line segment based reference line. Okay. almost like your line tool here, but instead of a line, it is creating it as a reference line. And similar scenario applies for your third type of reference line, which is an arc based reference line. So I can just click it, click on the starting point, click on the destination point, and the third point controls the intensity of the curve, right? So that way I can create a curved reference line. And in all this reference line process, you could define the axis for the reference line too. So in this case, if I want to create a reference line in my y-axis, x-axis, or z-axis, I could define it. Or you could even use your arrow marks in your keyboard to define the axis too. And the last important tool in custom modeling is your measure tool, which is nothing but your tape tool, using which you can measure a distance between 2 points, right? So here, can you see right next to the reference line, you have this measure tool, right? Shortcut is Z. Just click it, using which you can measure a distance. So now if I want to measure a distance between this line, I can just click it. It will tell me the distance. Or if you want to measure the distance between this point and this, click it, and it will show me the distance for all your custom model geometries. And these are all the important and most frequently used tools in your custom modeling. Okay. And just using different tools which are mentioned in this section, you will be able to create any component of your requirement. And this completes the basics of your custom modeling. So with this, your section 3 of the Day 4 professional course is completed.